Okay, so we're going to talk about measures of central tendency and dispersion. You can use different measures to interpret and compare sets of data. So these are probably all words that you guys have heard. So it says one way to summarize a set of data is to use a measure of central tendency. These measures can be mean, median, and mode. Okay, those are all measures of central tendency, which I'm sure you guys have heard before. There's also a poster in my room that you've probably read before. The measures of central tendency that best describe a data set depend on whether the data set has an outlier. So this will be a word that you see often. An outlier is a data value that is much greater or much less than the other values in the set. So if I said we had a data set of 1, 2, 5, 7, and 99, we can definitely look at this and say, okay, well, this is a lot greater than all of these numbers, so 99 would be an outlier. Okay, so below is a review of mean, median, and mode, and when to use the measures of central tendency. So the mean is often referred to as the average. So it equals the sum of all your data values and then divided by the total number of data values. So if we had, let's just say we had 1, 3, 5, 8, and 10. If those were our data sets, we would add all these numbers together. So add them all up and set them equal to whatever they equal, which, let's see, I'll do this math in my head real quick. Maybe 27, I think. And then you'd take that number and divide it by how many numbers you actually have in your data. So we have 1, 2, 3, 4, 5. So you'd go ahead and you'd divide that by 5. I don't know what that is right off the top of my head. Probably, let's see, 5.4, I think. But I'm not 100%, so please do not quote me on that. But that would be able to find the mean. So you add all your numbers together and divide by the total numbers that you have. Okay, so use the mean to best describe the data when it does not have an outlier. So the reason we do this is because if we were to add an outlier to this, say we added like 100 to this, and then divided by the total number, that's going to really bring your average up. So that doesn't accurately depict your middle of the set of data. Okay, so you only use mean whenever there is not an outlier. Okay, the median is considered the middle of a data set. So it's whenever your data is arranged in order, which means numerical order from least to greatest. For a set containing an even number of data values, the median is the mean of the two middle data values. I know that's a lot to kind of take in, but if we stick with our 1, 3, 5, 8, and 10, what you do in order to find the mean is you kind of cross off from both sides. So we cross one off from the greatest and the least, okay? And then we do the same thing, making sure that we do it on each side every time. And whatever our middle value is, that's going to be your median. So in this case, it would be 5. So we use the median to determine the middle of our set of data whenever there is an outlier. The reason we do this is if we were to add a big number to that, it's really not going to affect that middle value as much. Okay. Okay, the mode is just the number that occurs most often. So if I had 1, let's go ahead and add another 1 to that data, 3, 5, 8, and 10. 1 occurs 2 times, so that means that it would actually be the mode in this situation because it occurs the most often. Every other number only occurs 1 time. So a data set can have no mode. It can have 1 mode. or it can have more than one mode. Okay, so we use the mode when the data is non-numeric, or when choosing the most popular item. So what that means is if we were choosing our favorite color and we polled our class and said, okay, well, what's your favorite color? And we had 15 people who said blue and 5 people who said red, 2 people who said yellow. Well, the most common answer would have been blue. So that would have been a good indication. So that's whenever, like I said, you're using non-numeric. And in all honesty, we really won't use mode to ever describe our data. Okay, so I know that's a lot of information kind of thrown at you, but we're going to go ahead and we're going to do a couple examples so that we can best understand this. Okay, so number 1, it says, what's the mean, median, and mode of the bowling scores shown below? So we have 8 different bowlers and we have all of their scores. The very first thing you always want to do is go ahead and arrange your data in order from smallest to greatest. So if we look, we have 104 is our smallest, and we have 3 of those. So we have 104, 104, and 104. Our next smallest number is 109. Then we have 113. Then 117. 136. And 189. So, if we want to find mean, and you come back up here and you look, mean is often referred to as the average. Okay, so it equals the sum of all of the data and then divided by the number of data sets you have. So in this case, we're going to take 104 plus 104 plus 104 plus 109 plus 113, 117, 136, and 189. Okay, so that gives us a total of 976. Now, that's not our final answer because now we have to divide that by the number of data sets we have. So if you count your numbers, we have 1, 2, 3, 4, 5, 6, 7, 8, which would make sense since we have 8 bowlers. So we're going to divide that by 8. And once you divide that by 8, you actually get 122. So our mean value is 122. Now we want to go to median. So if we look back, sorry, phone's ringing. If we look back at our definition, median is the middle value in a data set. Okay, so we're going to go ahead and we're going to cross off one from the least side, one from the greatest side, one from the least side, one from the greatest side, and keep doing that until we find our middle values. Now, the problem here is we have 2 middle values. It tells us for a set containing an even number of data values, the median is the mean of the 2 middle data values. So we have to take the mean of these 2 values, and the mean we know is taking the average. So adding them together and dividing by the number of data we have. So in this case, we have 2. Okay, so 109 plus 113 and divided by 2, which gives us 111. The mode is the number that occurs the most. Okay, so that is going to be 104 in this case because 104 occurs 3 times. None of the other numbers actually repeat themselves. And then our final question here is asking us which measure of central tendency best describes the scores. So if we look back up here, I told you that we're probably not going to be using mode because these are numeric values. So we need to look between mean and median. And the difference between using these is whether or not they have an outlier. Okay, so we have to figure out, does it or does it not have an outlier? If we look at the data, I would consider 189 to be an outlier because it's a lot larger than the other numbers. So since we do have an outlier, we're going to say that the median is the best measure of central tendency. I hope this is making sense. Okay, again, here we're going to do the same type of thing. Okay, we're going to be finding the mean, median, and mode. So the first thing that you have to do is order your data from least to greatest. So we have 72 as our smallest number. Then we go to 77. Then we have another 77. Then we're looking at 82, 85, 87, 88, 90, 91, and 95. So that's all of our data in order from smallest to greatest. For mean, again, we have to go ahead and add all our numbers together. So we have 72 plus 77, 77, 82, 85, 87, 88, 90, 91, and 95. Okay, so we get 844. And we have to divide that by the number of data values we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we're going to divide that by 10. And that gives us 84.4. It is okay to get decimals. Okay, from here we can find the median. Since they are already in order from smallest to greatest, we're going to cross off one from our least, one from our greatest, and continue to do that until we reach the middle. Okay, again, we have two values in the middle, so we take the average of those by adding them together and dividing by 2. If you do that, you end up with 86 as your median. And then our mode, if you look, it looks like 77 is going to be our mode because it is the number that occurs most often. With this data, it says which measure of central tendency best describes the scores. If you look, we really don't have an outlier here. We don't have a number that just stands out as really, really little or really, really big. So we can go ahead and say that the mean is going to best describe this because we don't have an outlier. Okay. So it says a measure of dispersion describes how dispersed or spread out. If you think about dispersed, it's just kind of talking about how spread out the data is. So the values in a data set, whenever we're talking about how dispersed they are, we can find the range. And the range of the data set is the difference between the greatest and the least data values. So we know that difference means subtraction. So basically what you're doing is you're taking the greatest and you're subtracting the least. Okay. So if we look at number 3, it says the closing price in dollars of 2 stocks for the first 5 days in February are shown. What is the range and mean of each data set. So we're going to say range and the mean. Okay, range, again, we just talked about it, is our greatest minus our least. So we're taking our biggest number here, 47, and we're subtracting our smallest, which is 25. So 47 minus 25 gives me 22. So I have a range of 22. The mean, with mean, you don't technically have to arrange your data in order. That's really so we can find the median. But for mean, you're going to add your data together. So add all your data together, which gives us 160. And you're going to divide by the number of data points you have. So we have 1, 2, 3, 4, 5. So we're going to go ahead and divide that by 5. So we get 32. And we're going to go ahead and do that for stock B as well. Okay, so range. We're looking for the range of our greatest minus our smallest. So we have 36 and 28. So 36 minus 28 gives us a range of 8. And then our mean, again, we're adding up everything. So 34 plus 28 plus 31 plus 36 plus 31 equals 160. And we're going to divide by the number of values we have. So we have 1, 2, 3, 4, 5 again. So divided by 5. And that gives us 32. Okay. It's asking us to do the same thing for number 4. It's just shown a little bit differently. It says for the same days, the closing price in dollars of stock C were 7, 4, 3, 6, and 1. And then for stock D, they were 24, 15, 2, 10, and 5. So again, we have to find the range and the mean for each of these. So if we look at stock C, the range is our biggest number minus our smallest number. So 7 minus 1 is going to give me 6. And then the mean, we have to add up all our numbers. And then divide by the number of data points we have, which it says, again, for the 5 days in February. So we have 5 data points again. So divided by 5, and we get 4.2. Okay. Then we look at stock D. Okay, so our smallest number is 2 and our greatest number is 24. So if we take 24 minus 2, we get 22 for our range. And then for mean, we have to go ahead and add up all our points again. So 24, 15, 2, 10, and 5, and we get 56. And we're going to divide that by 5 again, and we get 11.2 for our mean. All right, let's look here. We have a few more questions. All right. So the results of a survey on the number of televisions in student households are shown in the line plot. So we want to calculate mean, median, and range of this data. Okay. So this kind of graph, what this is saying is you have a 1 and then you have another 1. So I'm going to list out my data set. Okay, then you have 4 2s. So we have 2, 2, 2, and 2. Then you have, let's see, 6 3s. Then we have, again, 4 4s. Then we have 2 5s. So if we want to find mean, I know it's going to be a process, but we have to add up all of our numbers together. So let me go ahead and do that real quick. Let's we end up with 54. 54 is not our answer, though. We have to divide that by the number of data sets we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we're going to take that 54 and we're going to divide it by the number 18. And we get a mean of 3. So that means on average, there's 3 televisions in a student's household. Okay, so for median, we have to start crossing off from both sides. Okay, and we get 2 3s in the middle. So what you have to do here is you have to take that 3 plus 3 and divide by 2, which still ends up giving you 3. So you're taking the average of the two, but since they're the same number, the average is just going to be the same. It's going to be 3. Okay, then for range, we take our biggest number, which was 5, and we subtract our smallest number of 1. So 5 minus 1 gives me 4. It asks us a pretty good question here. It says, how can you tell from the graph that the mean and median are equal? The reason why we can tell this is because we have a symmetric graph. Okay, we have a middle peak, and then it's very, very similar on both sides. So if I were to draw a line down the middle, it's going to be almost, well, in this case, it actually is identical on both sides. So we can tell because the graph is symmetric. All right, moving on. Okay, so again, we're going to do the same thing with number 6. I'm going to go ahead and list out my values. If you look here, I have 4 x's for 19, so that means that I'm going to have 4 19s. I'm going to have 5 20s. Okay, I'm going to have 6 21s. Two 22s, 2 23s, and a 24. So, finding mean, you have to add all these together. So, let's go ahead and do that. I know it's going to take me just a minute. And let's see, I got 392. Or I'm sorry, 397. So if I get 397, I'm going to go ahead and I'm going to divide that by the number of data I have. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So I'm going to go ahead and I'm going to divide that by 20, and I get 19.85. Okay. Now for median, I'm going to cross off on both sides. So one from my least, one from my greatest, and continue to do that. So again, we get left with 2 numbers in the middle that are the same. So whenever you take the average of those, it's just going to be the same exact number of 21. For range, we're taking our largest number and subtracting our smallest. So we have 24 minus 19, which gives me 5. So my range is going to be 5. And it says, how can you use this line plot to determine whether the mean and median are equal? Well, clearly we don't have a mean and median that are equal. But the reason for this is it's not a symmetric graph. So in the example above, we had a graph that was symmetrical, which means that the mean and the median were the same. But this graph is not. It's actually skewed more to this side. So because the graph is not symmetric, we can conclude that the mean and median are not the same. You could have also said because the graph is skewed, that would have worked also. And in this case, since it has more of your numbers to the left over here, I would say this is left skewed. Okay, number 7. It says the results from the same quiz given to 2 different classes are shown below. So this is our class A. This is our class B. Okay, so which class has a higher standard for being in the top half of the quiz scores? So it says use the median. So if we're just looking at these graphs, I don't want to do any calculations and I'm just looking at this graph. We should know that the mean and the median are going to be the same for class A. The reason is because this is a symmetric graph. Okay, for this one, our data is more to the right, so it slowly increases as you go to the right. So this is a skewed graph, which means that our mean and median are not going to be the same. Okay, so in this case, it says which one has the highest median. Well, more of our data is over to the left here, which means that we're going to have a higher median for class B. Okay, and then it says by comparing the line plots, how can you tell which mean is greater? Well, now we're talking about the average, and since we have more bigger numbers for class B, we can then say that the mean is also going to be greater for class B. Okay, it looks like we need number 7 for this next part. So it says use the results from class A and B above along with a third class. So now we've thrown in a class C. Okay, it says is the mean for class C greater than or less than the mean for class A? In this case, again, just looking at the shape of our graph, we slowly decrease. So again, we're going to have a skewed graph here. But in this case, we're skewed to the left, which means we have more lower scores in this class. So our mean is actually going to be less than class A. Okay. Is the median for class C greater than or less than the median for class A? So median again here is going to be right in the middle somewhere, okay, since it's symmetric. But since class C is skewed to the left, we, like I said, have a lot more smaller values here. So again, it's going to be less than. Okay, and then it says, how can you tell which data set has the greater mean by comparing the graphs? Well, we've kind of already talked about this. It's the shape. We can say that class B is going to have the largest mean because we have more students that did well because most of our data is over to the right. These are important questions. They show up a lot on SAT and are also just very good questions to know. It's kind of using what we've talked about and setting it into real life. So your grades on 3 exams are an 80, a 93, and a 91. What grade do you need on the next exam to average a 90 on your 4 exams? So if it's saying average, we know that average means mean. And with mean, we know that we're adding all our data sets together. So we have 80, we have 93, and we have 91. But it's also talking about a fourth test. So it says, what grade do you need on the next exam? Well, we don't know what grade that is yet. So we're just going to say plus X. We don't know that yet. Okay. And then in order to find average, you have to divide by the number of data sets you have. So we have 80, 93, 91, and we also have this X that we don't know yet. So that's a total of 4. And we're going to say that that's equal to the average, and it's telling us the average is 90. So that equals 90. Over here on the left side of our equation, we're dividing. Okay, so in order to get rid of that division, we don't want that divided by 4 over there. Sorry, getting crazy. Okay, so what we're going to do in order to, like I said, reverse that division, we're going to have to multiply. So we're going to multiply both sides by 4 to get rid of that denominator of 4. So that basically just crosses everything out over here besides the top part. So you're still left with 80 plus 93 plus 91 plus X. But this time you're going to say, well, that's equal to 90 times 4, which is going to be 360. Now we know to go ahead and combine like terms. So we have 80 plus 93 plus 91, and we get 264 plus X equals 360. I'm going to go ahead and I'm going to write that over here. Well, we know how to solve this. We can just subtract the 264, if I can write, on both sides. And we get X equals 96. So that means that we need a 96% on our next exam to keep an average of 90 on all 4 exams. Okay. The next problem is almost identical to this one. All the next problem is saying is the grades in example 2 are the same, okay? What grade would you need, which it should say example 8, sorry. So what grade would you need in order to get an average of an 88 instead of a 90? Okay, so we're going to do the exact same method. We're taking 80 plus 93 plus 91 plus X. All of that divided by 4. And that's going to give me an average of 88 instead of 90. That's the only difference. Okay, so again, we have to get rid of that 4. So we are going to multiply both sides. Because if you multiply one, you have to multiply the other side. So we're going to get rid of those. We already know really that 80 plus 93 plus 91 gives us 264. We already did that math in the previous example. And we're going to say, instead of 360 though, 88 times 4, which gives us 352. Okay, and then I can go ahead and subtract the 264 on both sides. And I get X equals 88, which means in order to have an average of 88, I have to get an 88 on the next test. Okay, I think that's it for this lesson.